All right, good evening, everyone. Welcome to Qualcomm's auditorium. We're really happy to host you here this evening. I'm Bill Davidson. I'm Senior Vice President of Investor Relations. That's my Qualcomm business card. I also have one from one of our subsidiaries. I head up sales and marketing for Firethorn Mobile, where we're trying to pioneer mobile commerce. And I'm also very proud to be a CommNexus board member. I was asked beforehand, I think I'm at about the 6.5-year mark with CommNexus. So really great to see you all here, and really happy to have such a good turnout. Now, I got a call. So how many of you have had the chance to meet or interact directly with Rory Moore? Probably a lot of you, yeah. So he called me to say that he was going to stay after Mobile World Congress to take his wife on a very long-needed vacation, and he said, Bill, you have to be me for the event, and so since so many of you met him, you know there is no way that anybody can be Rory. So I'm just going to say that I'm going to be a reasonable facsimile, but certainly in no way a replacement for him. Let's see how we're working. Perfect. It's to me really important to acknowledge the companies that make these events possible, and they're listed here in front of you. Without the companies that you see listed here on the screen, we wouldn't be able to put on the great programming that CommNexus provides to the San Diego community, including many of which they're offered pro bono to the community. These companies provide their financial support, and if you're an employee working for one of these companies, you're attending tonight at no additional cost beyond your company's membership in CommNexus. So I would ask those of you that are paying to be here tonight, number one, thank you, but two, we'd love to have your companies join CommNexus, and that way even more of you could attend our events. Tonight specifically was made possible by AIS Cox and yours truly, Qualcomm. They're sponsors for this evening for the hospitality and the programming tonight. So if you see someone from there, please make sure to thank them for helping put this evening together. Recently, we elected this fine-looking gentleman as our new head of CommNexus, Mike Salfidi, CTO of one of HP's largest groups, the Imaging and Printing Group. So please welcome Mike. He's sitting right here in the second row. And so great. I was sharing the story ahead of time with our guests this evening about, who is CommNexus, and just so great to see the diversity in the membership from when it was originally the San Diego Telecom Council. So really a good representation, good cross-section of the business community, not only locally here in San Diego, but extending beyond that now. Wanted to just touch on MarketLink. It's been a very successful program introduced a few years back. It's, again, a pro bono program where we bring multinational organizations to San Diego to meet with emerging companies for potential partnership opportunities. And so we've introduced 80 companies to these corporations in 2012 and 2013 combined, so a great feat there. The next one is with Verizon. They'll be here May 15th and 16th. And listed are the areas of interest. If your company meets their needs, definitely apply. Applications open March 11th, and it is, again, pro bono, totally free program. Another really great thing that's happened here, I remember Rory visited me a few years back when we hit the financial downturn, and with the Admiral and some others, and they had a clear goal, which was we don't want to see good talent leave San Diego as a result of the downturn. We don't want to see good engineers go. We just don't want to lose talent from the community. And they had this idea about how to create an incubator, but in a very unique way. And that was to make it a 501c3. And, of course, we wish them well on what would prove to be a long process to get that designation, but the group achieved that. And we've now incubated 39 companies out of EvoNexus who have raised $144 million in total venture funding and created more than 600 jobs, all in 3 years. So if you have any experience working with incubators, failure is usually more the rule than success. I haven't seen too many of these work. And I think Rory would tell you this has become a model for others, and we've had interest from others on how to replicate the program we've done right here in San Diego. So it's just a wonderful story. Later tonight, you're going to hear from our panelist, Norm Feldheim. Thanks again, Norm. I put the squeeze on him with it being in the Qualcomm Hall. He agreed to participate. Our CIO, Steve Philpott, CIO of Amylin Pharmaceuticals, and Amy Chu, VP of Information Technology for SDG&E. By the way, Amy, since moving here 10 years ago, I've lost my power once, and in the Northeast it was about 5 times a week. So I'm a huge fan of SDG&E and the quality network that you have out there. Yeah. And then now, let me move on. I'm really honored to be introducing our keynote speaker this evening, Dr. Timothy Cho. Dr. Cho is a nationally renowned authority on cloud computing and an award-winning speaker. He was the former president at Oracle On Demand and is currently a lecturer on cloud computing at Stanford University. So with no further ado, please help me welcome Dr. Cho.
As I'm walking up the stairs, I'm trying not to be Jennifer Lawrence, right? So, thank you all for being here this evening. Thank you, Bill, for the kind introduction, for CommNexus inviting me here. It's really, when you're at 6:30 at night, you definitely have to find a way to be entertaining for people. So I hope I entertain you a little bit. I would give you a little bit more of my background to really kind of give you a better understanding of why I'm going to say what I am. I actually came into this whole world of cloud computing a little bit over 10 years ago when I went back to Oracle to work for Larry running what we called Oracle On Demand, which was really a very early version of delivering applications as a cloud service. And when I left in 2005, 2006, I felt like we were at the beginning of something very significant. In fact, I think that this shift we're making is as significant as the shift to client-server computing that we made a long time ago. And we are probably in year 2 or 3, and the same economic forces are at work here. And so I decided a couple things. One, I devoted some of my energies to going back into the university world, and as was introduced, I teach class at Stanford. I also teach a class at Tsinghua University in Beijing, and spend a certain amount of time trying to get the young kids understanding what this is all about, because I really think it's going to shape the future of the economy. In fact, some of what I will talk about at the end hopefully will touch on what that means. Before I go a lot further, one of the things I've noticed, because I do a reasonable amount of public speaking, is that people in the front row are looking at me and they're trying to figure out why I look like this, but I sound like this. It's okay, you can admit it. I know. So I grew up in the great state of North Carolina, so if you are detecting any southern thing there, that's what has happened. But I've lived in the Bay Area now for going on 30 years. So, but you never lose some of that you got, what you grow up with. So, what I hope today is to teach you a couple lessons that will give you long life in your careers. But what I'm going to start out with is something more important, which is long life in your personal life. So this is actually taken from a temple in Kyoto, Japan. It is believed to be over 500 years old. It contains the 10 secrets to long life. So I see you all have your pens out, you're writing this down, you're copying it. Okay, so you don't speak Chinese yet, so I did a translation for you. So you're supposed to eat more vegetables and have less meat, and more sleep and less worry, more laughter and less anger. And then the one I've always found amusing, the more bathing, less clothing. Right? So if you're a monk 500 years ago, there's no television, right? So you have to have something to entertain yourself. So I'm going to split my talk into 2 parts. I'm going to try to give you, I think of it as 2 TED Talks in one night. So the first part I want to talk about is the subject that is on the agenda, which is migrating to the cloud, which I think of it this way. I will tell you a little story. This is about 1.5 years ago. I was with a very large company. You would know their name. And it is so large, there are 6 CIOs. And they're sitting around the table. I'm not actually there to talk about cloud computing, but, we're doing the introductions. And so, hi, my name is John. And I said, John, what do you work on? He goes, I'm working on a strategy to move to the cloud. Went to the next person. Oh, my name's Mary. What are you working on, Mary? Oh, I'm working on a strategy to move to the cloud. We went all the way around, all 6 of them, strategy to move to the cloud. So they got to me and I went, I just have one question. What does that mean? And they all looked at me and they went, we don't know, but we're working on it. So what I want to do in the next 15 minutes is do what I did with them, which is try to give you a way to think about what is happening here in some constructive way. So those of you who are running IT shops and whatnot, as you try to think about what it means to migrate to the cloud, or by the way, if you're a vendor and producing this stuff, what does it mean to help a customer do this? What does that mean? Okay? So I'm going to start by talking about cloud computing in a way that you can go home and explain to your Facebook friends. Okay? So I'm going to start at the top, which is we all have been using, and I'm going to there's going to be no buzzwords in this. We have all used consumer application cloud services, right? So whether that's Twitter, Facebook, eBay, or I go to my favorite banking website and move money from savings to checking, we are using consumer applications as cloud services. Now, it didn't always used to be this way, right? Once upon a time, we used to get software, install it, etc. And just to remind yourself how much things have changed, about 6 months ago, one of my Stanford kids was saying, well, I really want to understand this thing about cloud computing. I said, okay, fine. So we go out to breakfast. And I start out the very same way. I said, we all use consumer application cloud services. It didn't always used to be this way. We used to have to install software, blah, blah, blah. And she looks at me and says, oh, yeah, I've heard about this. It's called a floppy disk. Right? I can see there's some old people in the room, right? So it didn't always used to be this way, right? Now, what you may not realize is that in the world of business applications, we have moved very far in this direction, right? There are a ton of business applications which are now available as cloud services. In fact, just to give you a representation of this is actually beginning in 1999. Literally every software company who delivers business applications is only delivering them as a cloud service. And just to give you a sense of this is actually the year that they made their public offerings. It ranges from companies like Concur and Expense Management. Kintera, actually, which is a local company, was acquired by Blackbaud several years ago in the nonprofit space. Salesforce, you all know about probably in the CRM. Right now in the services space, Vocus in PR, Constant Contact in email marketing. The area of HR has been, very, very good for people. SuccessFactors, Taleo, Connexa. In fact, if you follow this, last year, every one of them got bought, one by Oracle, one by SAP, and one by IBM. I put OpenTable up here because just to give you, probably most of you know, most of you used OpenTable? Yeah. So OpenTable on the one hand is obviously a consumer application, right? That's the way we all use it, to reserve a dinner or whatever. But on the back end, right, it's a restaurant system. And so in that sense, they are a business application, right? So at this stage, pretty much everybody, as I said, is moving this way. In fact, many of the advanced companies at this stage are only buying business applications as cloud services. I did an interesting, I had to do a talk about 2 years ago to the 40 largest company CIOs in the world. So I happened to know who was going to be in the room, and I happened to know the CEOs of about 6 of these companies up there. So I did an informal survey, and the results were that 38 out of 40 of the largest companies in the world were running one or more of these applications. So in a lot of ways, when people say, what do you think corporations are going to move to the cloud? I'd say, well, there's some evidence this has already happened. Okay? Now, these all use the original cloud. Now, a lot of people have asked, well, why do we call it cloud computing? I said, well, it's actually fairly simple. This dates back to the days when we used to sell client-server. We all used to walk in, we draw a picture of a PC on the board, we draw a picture of a server, we draw a little cloud, and we connect the two. Mostly because none of us understood how networks worked. So, well, it goes in the cloud, and the bits come out, and it all works, right? So the original cloud is the network cloud. Some of you may remember words like BNA, SNA, X25, SDLC, HDLC. The old folks in the room are nodding their heads, right? So, right, all that technology was there to go build corporate networks, right? Once upon a time, we used to have corporate networks. That's not the case anymore, right? Everybody's using IP/MPLS-based networks from a variety of network cloud service providers, okay? Now, these guys over time realized that, well, God, you know, I have to put my switches and routers in rooms that are cold, have guard dogs out front, and are not located on a fault line, right? So, crap, if I've got switches and routers in there, why can't I put computers and storage? And so really, in the dot-com boom, a lot of these data centers started to emerge, right, providing what I would call data center cloud services. In fact, amusingly enough, fairly recently, we're seeing a lot of acquisition occurring here. Terramark was bought by Verizon, Savvis by CenturyLink, et cetera. I'm not going to spend a lot of time in data centers, although they're very interesting things. But what I'm going to point out to you is one thing, which is one of the huge operational costs of a data center is the cost of power. And the other implication of the cost of power is the cost of carbon. Because if you think about it, right, and you probably have never thought about this, but you will tonight, a server and a human have about the same carbon footprint, okay? So if the number of servers I have in my business is more than the number of employees, then my employees can drive SUVs all day to work, right? It won't matter. The carbon footprint is all in the computation. So I got curious and created this metric called servers per employee. So you all can do this, right? Just take total number of servers you have, virtual, physical, big ones, little ones, I don't care. Add them up. Divide by total number of employees, contractors, include them all. Okay? Have a number in your head? Okay. Turns out, the U.S. government actually tracks this number for developing economies. Because if you think about it, right, that if the servers per employee in a developing economy is 0, what is the chance for global economic development? About 0, right? So it turns out Brazil sits at about 0.04, India sits about 0.02, okay? The next clump of numbers you see up there is all the guys who deliver applications as cloud services, which means guys like Salesforce and Connexa and Taleo, et cetera. So they sit around 0.5 and 1.0. Now, my strong suspicion is most of you guys in this room are sitting between about 0.2 and 0.5. In fact, that dot up there that says 70,000 servers on it, that's actually one of the largest financial institutions in the world. And they're sitting at about 0.35. I made the mistake a couple years ago. I have a friend, Ramon Baez. He was the CIO at Kimberly-Clark, and he just moved to be CIO at HP. And he was sitting in the front of the audience, and I said to him, I go, well, Ramon, what's your number? Right? He goes, oh, my number's 0.4, but we're headed to 0.2. And I went, uh-oh. Because he thinks I have asked an efficiency question, right? So 0.2 is better. So I put this slide up, and I said, so who do you think's sitting there at 30 to 1? Any guesses? No. Facebook. And who's sitting at 50 to 1? You guys already said it. Google. And these, by the way, are probably underestimates at this stage. Now, I want you to think about two things. One, do you think they're inefficient? Two, what the hell are they doing with those machines? Does it take that many servers to serve up a web page? Okay. We'll keep on going. Okay. What got everybody excited a few years ago was when Jeff came out and said, not only are you going to be able to buy CDs and DVDs and all that stuff from me, but you're going to be able to buy compute and storage. And for most of us in the industry, we looked at this and went, well, this is stupid. Why is he doing this, right? But it turns out, and they do not release public numbers on this, but it's widely believed that they went from 0 to $1 billion in 4 years, right? Meteoric. Which is why, basically, everybody and their brother has jumped into this, right? Because applications only mean something to a small group of people, right? To sales guys or marketing people or whatever. But when we're talking about compute and storage, it means something to everybody. And so whether you're talking about large companies or small companies, right, everybody's in the mix here. So what I want you to think about, though, is what is happening here is not a technological innovation, okay? Yes, it requires virtualization to implement this, but the innovation was a business model, right? The ability to now deliver you a computer for 12 cents for an hour and then let you give it back to them. That economic differentiator is creating whole new things that we've never seen before because they are now economically viable. They've always been technologically viable, but they're now economically viable. So I'm going to touch on 4 examples to kind of share with you things for you to think about. So the first ones I'm going to talk about high growth applications. So who in this room knows who the Gilt Group is? Oh my goodness. And it's even guys knowing who the Gilt Group is. God, your girlfriend's wives must be big spenders. Okay, so I won't call on anybody, but basically the idea is this for those of you who have not experienced the Gilt Group, is so it's a high-end spot auctioning site so that you can buy Prada handbags for $15,000 instead of $20,000. Okay? Now, I have to tell you, the first time I heard about this business, I'm going, how many people would ever do this, right? Well, clearly there's many in this room, right? Again, they don't release public numbers, but it's believed that in 2.5 years they hit $300 million. And actually, Gilt, I think, was supposed to file this year to go public, right? Now, think about it. If you're an IT professional, think about what this means. We're growing from 0 to 300 million in revenue doing spot auctioning, right? Tons and tons of transactions going through this system. So what is going on in the background? I'm showing up in my boss's office going, need a new computer, need more storage, need another power supply, need another rack, need another building, need another data center, right? Okay, we've all done this, but these guys didn't do that, right? They run completely on a compute and storage cloud service. So as the business has grown, they just dial up more and more compute, more and more storage capacity. Which is why, and it's probably no news on this subject, every startup in the Bay Area who thinks they're going to be the next Groupon, Facebook, right, Twitter, etc., is building in this way. In this sense, we're already over on the other side, right? Okay. Next category of application, what I'm going to call aperiodic bursty apps. So what does April 15th, February 14th, and the end of January have in common? Okay. So April 15th, you're going to tax day, right? So what you probably don't remember is a couple years ago, the Intuit website fell over on April 15th. 300,000 people could not file their taxes, right? It wasn't a very pretty thing. February 14th, you may have never thought about this, but it is the #1 day for e-cards on the planet because you don't send them on February 13th and you certainly don't send them on February 15th, right? So February 14th, all traffic. It's enormous spike of traffic. End of January, which is creeping in the beginning of February, Super Bowl Sunday. So 2 or 3 years ago, Denny's and Dockers both ran multi-million-dollar ad campaigns to drive traffic to their websites. Denny's for a free breakfast, Dockers for a free pair of pants. What you probably aren't aware of is within 60 seconds of the multi-million-dollar ad running for Dockers, the website fell over. Actually, just to make a parenthetical comment, if any of you guys were looking at it this year when Coca-Cola ran the ad for picking between the showgirls and the whatever, their site actually was down for most of that event, amusingly enough, even after all of this. Okay, why did I tell you all these stories? Well, all of these could have been found technologically, right? I could have built, all it is high volume load testing, right? I would have brought up a bunch of load, bought servers in San Francisco, New York, Miami, etc., hit the websites, found the bug. In fact, it's believed that the bug was actually found at Denny's the week before, right? But it's enormously expensive to go do that, which is why nobody did it, although probably the Dockers guys should have. Today, you can ramp up thousands of servers for an hour, a day, a week, etc., ramp them all the way back down. And so suddenly something which has always been technologically possible is now economically possible. I know I'm a center of biotechnology, so for some of you this may not be news. For the rest of you, you may start to think about this. Biology has become chemistry. Chemistry has become computation, right? Enormous amount of things are happening computationally out there. This is an interesting case study. So this is Pathwork Diagnostics. They do tumor diagnosis. Just a short introduction of that. Apparently 75 to 80% of tumors can be diagnosed by visual inspection. The rest of them, the current technology is I run a bunch of chemistry, I get protein high, protein low. Oncologist kind of tries to make sense out of it, defines a protocol based on that. These guys said, well, that's kind of a dumb way of doing it. Why don't I assemble all of this data together from thousands of experiments, run big machine learning algorithms against it, and come back with a probabilistic determination of what kind of tumor it is. So that's what they do. Literally 2 times a year for 6 weeks, they ramp up to 1,000 servers, they run big machine learning algorithms, and then they shut them all the way back down. Now, think about this economically speaking. They're running, let's call it 12 out of 52 weeks in a year. So right away, we're at 20% of the cost, right? Now, could they have, and actually they did start this way, buy thousands of servers, put them in data centers, et cetera? Yes, but economically, this is a much better model for them. So I'll end with what I call periodic bursty apps. This is actually an example out of financial services. So what happens here is every trading day during the day, the system actually has 300 servers sucking data off of commodities, futures, et cetera, exchanges. At night, it ramps up to 3,000 servers. They're doing risk analysis algorithms. The next morning, they present risk profiles to their traders, and then they cycle this all over again, right? So do trivial math, 40 hours a week out of 200, at the fifth the cost. But something more important is going on here, right? The ability to take risk. Now imagine for a second that I had gone into my boss and said, I've got this really cool idea. We're going to get 3,000 servers and do risk analysis algorithms. And we went and bought the servers, put them in data centers, et cetera. And then 3 weeks later, I went back and I said, it didn't really work out that well. Do you think I have a job the next day? Here, right, fine, right? We'll shut it all the way down, no problem, right? So again, economically changing the landscape. I want to finish, for those of you, with 2 last categories for you to think about. So the first is software development. So if you remember the last time the war was fought, the client-server war, the guy that won the battle won the developer, by the way. So the battle is being joined one more time, right? And I will tell you that developing software in the world in which the distance between my finishing the development of it and it going live is measured in, let's call it hours and days and weeks and not years, is enormously different, right? And so new structures are being produced. The old guys are in it, Microsoft, et cetera, in it. But there's a lot of new players. And so if you are at all building software out there, I'd strongly encourage you to start playing with this stuff. It is changing what it means to build software. I will give you a simple example. There's a company actually who is building an application to help companies file their 10K, 8Ks, et cetera. It actually, half of it runs on Google's App Engine, and half of it runs on MySQL running on Amazon's Web Services. Very different way of thinking about building apps. Okay? And the last category is, if you are going to have an application, whether it's a on-premise traditional application or whether it's a new cloud-based application, you're going to have to manage the security, the availability, the performance, the change in those applications. You don't want to do this with human labor. You want to do this with software. So there's a whole new generation of operations management software being built out there. Just give you a trivial example of this is spam filtering. Once upon a time, you'd go buy spam filtering software, install it on your PC, right, run it, etc. Nobody does that anymore, right? They go use Postini or Message Lab or a dozen different applications out there. And this is true across an enormous spectrum, okay? So this is, again, very early days, but for those of you starting to think about managing new applications, you need to think about this. So I took you all the way back up to the top. I didn't use any buzzwords, I think. And I hopefully explained to you what is happening in a way in which you might find useful. So why would you find it useful? So let's start, right? We said, what does it mean to migrate to a cloud service? So I'm going to tell you there are 7 different meanings to this. So let's just pick on an application, and just for the fun of it, I'll pick on Siebel. So if I said, okay, I've got a Siebel application, the first thing I could do is I go, well, I'm going to move to a new network cloud service, which is faster and more reliable, etc. I'm going to move the Siebel application to a data center, which has got colder air and bigger guard dogs out front, right? Third thing is I could move to a new compute and storage cloud service and, in essence, trade this whole CapEx for OpEx conversation. The fourth thing I could do is I could go, there's not much of that application I've ever really used. I'm going to rewrite that part of it in a new software development cloud service. And just so you don't think it's crazy, people are already doing this. The fifth thing I could do is I could say, well, I've got to manage my existing Siebel application, so why don't I use a new generation of operations management software to manage it? The sixth thing I could do is I could go back to the vendor, which at this stage, everybody in the space is starting to do this, right? And say, hey, why don't you take over managing the application, the software you sold me? And obviously, the seventh thing I could do is go, yeah, I'm going to replace the Siebel application with Microsoft CRM, Salesforce, etc. Okay? So for those of you who are running IT shops, my counsel to you is sit down, go through the portfolio, do an analysis of this. It may be an interesting result that you come up with. But in the end of the day, I think you end up with an actionable plan for migrating to the cloud. Okay? So I told you I'm going to give you 2 TED lectures in one, right? So that's very practical, pragmatic. Hopefully it made sense, and it really is telling you where we are today, okay? Most of what people are thinking about today are really all have to do with operational efficiencies and reduction of cost. I'm going to tell you I think the future holds much more than that. But first I'm going to tell you the world is changing, and I'm going to start at the bottom layer. The world is changing at the most fundamental layer. So just for the fun of it, I did a little analysis for those of you who don't think much about hardware. So this happens to be the profile, 267,000 employees, 70,000 servers, and 70,000 terabytes of one of the largest financial service companies in the world. Okay? Which is, by the way, less than 0.4 servers per employee. Today, you can actually get a rack of computers at 1,000 cores and 2 petabytes in one rack. So if you think about it, right now, one of the largest financial service companies in the world could run on 150 racks in less than 2.5 megawatts and cost less than $25 million. The whole computational infrastructure. If you take it to a Fortune 500 company, that's why gargantuan. A Fortune 500 company which would have, let's call it 30,000 employees, and I'm using the same ratios, 12,000 servers and 12,000 terabytes, you now in this technology could be running in 25 racks in less than a half a megawatt. Which means, I know my friends at AIS have 6 megawatts out there. You could actually run, if you think about it, 12 Fortune 500 companies in there. It's enormously different what is happening out there from a hardware infrastructure point of view. Okay? So what this should lead you to start to think about is, what are we going to do with this? Right? I mean, today, really all we have done is, I'm calling it transaction processing. That's pretty much the state of the art of what we've done. So what is ahead for us? So I told you, well, I may not have said it. The Amazon guys, I've known them for a long time. Said I teach a class at Tsinghua University, so about 4 years ago, they said, well, here's $3,000 worth of computer time, right? And I said, oh, well, that's cool. So I showed up at class. I said, we got $3,000 worth of computer time. And I did the math. $3,000 is about 3.5 years of a server, and you could pick Northern Ireland, Virginia, or California, right? So they all looked at me in class and went, yeah, so I can have a server in Beijing for 3.5 years. I said, or $3,000 buys you 10,000 servers for 30 minutes. Now, nobody's been given 10,000 servers for 30 minutes. And that is going to start revolutionizing things. And I want you to think about in what ways. First, we are going to end up with a bunch of what I'm going to call specialized compute and storage cloud services. I know there's always been a debate that, oh, well, at the end of the day, everything's going to run at Amazon or whatever, right? But that's patently not possible at this stage. You may never have thought about this, but I'll tell you. Basically, the industry today ships about 8 million servers and about 20,000 petabytes of disk out there. A de minimis portion is actually running in the cloud at this stage. In the long term, my belief is just as what we've seen in business applications, we're going to see it happening in compute and storage. It's going to happen by specialization of location. At this stage of the game, without ubiquitously fast networks, you're going to have compute and storage all around the world. Net of, obviously, the geopolitical conversations that go on about I'm not going to keep my data in that country, right? Technologically, you're going to have to do this by location. You're going to see specialization of compute and storage by security features, by performance features, by availability features, and by new business models. And I believe we're just at the very beginning of this in terms of what is going to be possible. Just to give you a small taste of this, one of the large stock exchanges actually getting ready to produce compute and storage cloud services, which are obviously optimized for trading applications, right? SITA, who some of you may know, is the large conglomerate of all the airlines. Actually, their networks connect all the major airports into their data centers. If I wanted to build an airline application, the performance and security characteristics of that specialized compute and storage cloud service are infinitely better than a lot of things else you would see. So we're seeing the very beginnings of this, but I would project to you we're going to see more and more of specialization in compute and storage. We're going to see specialization by application. So you're all probably really wondering, what's this doing up here, right? So you probably have never thought about this. But how big do you think the poultry industry is? And I'm talking about chickens, not turkey. Just so you guess correctly. So the poultry industry, chickens, not turkey, is a $100 billion a year industry. Okay? So let's just do the trivial math that we've all been taught, which is they should spend 1% on IT. So that means $1 billion a year. So why is there not a poultry management software company? And the answer is there will be, right? And I think what we're going to start to see again is specialization by application within domains, more and more and more of this. And the challenge is going to be, by the way, is how do we marry the guys who understand stuff about technology to the guys that understand stuff about domains. There's a huge challenge, believe me, at a university level and at an industry level. But the opportunity is there. So I'm going to end by getting you to think about something really big. So, you may not know this, but the U.S. economy is largely a services economy, right? In other words, we don't manufacture a lot, we don't build a lot of stuff, and we don't grow a lot of stuff, right? So almost everybody in this room is probably in the service economy. I mean, financial services, healthcare, software, all that stuff, right? So we're north of 80%, 85% of the U.S. economy is services. What's interesting to note, this is actually just coming out of the latest issue of The Economist, is even China, that we think of as being the manufacturing giant, the services industry is growing, right, by leaps and bounds. So the question you should ask yourself is, so what the hell is a service industry? What is it? Is it flipping burgers at In-N-Out? I get to say that around here, right? Flipping burgers at In-N-Out? Is it answering the phone nicely from the Philippines? Is that a services industry? So I'm going to say no. Service is the delivery of information that is personal and relevant to you. Service is the delivery of information that is personal and relevant to you. So whether I walk into the concierge at the Hyatt or whatever and say, I'm looking for a cheap Chinese restaurant that I can walk to, and he or she gives me the right answer, cool. Or I walk into my doctor's office and she says, based on your genome analysis and your lifestyle, we need to put you on Lipitor and you need to stop eating red meat. That's service, right? So I want you to start thinking about computers in this light. And for a second, imagine the Amazon website, okay? So visualize the Amazon website. I'm going to ask you a question. Where is the transaction processing system on that website? It's in the upper right-hand corner. It's that little thing called a shopping cart, right? And by the way, it's got to operate securely, reliably, at scale, all these other wonderful things, right? I'm going to ask you a question. How important is it? I'll go, well, kind of, not really, right? It's about that important, right? Now realize, most of us in the computer industry, I started out my career at Tandem Computers, for those of you who know. We spent all of our collective energies on building transaction processing systems, right, to accurately move money from savings to checking, to pay a bill, et cetera, et cetera. Most all of our efforts have gone into that shopping cart. What is the rest of that site trying to do? It's trying to deliver you information that is personal and relevant to you. We can debate how well it does it, but it's certainly trying to do that. Now, I'll take you to your favorite banking website, pick on our banking friends, and I'll say, when you log in, all you see is a shopping cart. The only thing that is there is a shopping cart to let you move money from savings to checking or buy a bond or sell a stock, right? It doesn't really care who you are. Now, could it deliver information like, well, people like you bought Qualcomm stock today. People like you refinanced their mortgage. People like you. I mean, I can just use the people like you. Could it? Hell yeah, it could. Why? You may never have thought about this, but the consumer internet is about 500 terabytes. That's really all it is. It's not very big, right? Every company on the planet, including the one we're sitting in right now, has got way more information in it than that. So what's missing? Why can't we do this? And I say, well, we're held hostage by the SQL monster. And why do I say that? Okay, let's pretend something. Let's go back in time about 15 years, and let's go sit in Mountain View. And you're all my engineering staff, okay? So I'm going to come in, I say, hey guys, I have a really great business idea. We're going to enable people to search all the information on the internet, and we're going to monetize it with ads. Hell of a business model, right? Okay. Now you guys are a bunch of SQL engineers. What are you going to go do? I project this. You're going to go design a master data schema for all information on the planet. You're going to then build ETL and data cleansing tools to import all information on the planet into the giant global data schema. And the third thing you do is write reports like, best place to camp in France. Okay, right. I think about $20 billion later in 200 years, we might have gotten done. They didn't do that, right? So all these technologies, and I give my CIO friends a nudge on this, all these technologies that have been developed in the consumer internet, people are making a mistake when they talk about consumerization of IT as a conversation about, do I let people use Facebook at work? I mean, okay, fine, have that conversation. The real conversation ought to be, what are these technologies that have been born in the consumer internet, and how can we use them to deliver service that is information, personal and relevant to you? And in that, remember I said 30 to 1 and 50 to 1? 30 to 1 and 50 to 1 is telling you how information-powered those businesses are. Ultimately, if every service business is an information business, the guys that are successful are going to be doing 30 to 1 and 50 to 1, not because of inefficiency, but because of the ability to harness these technologies to deliver service that is information, that is personal and relevant to you. So for all of you who are at the beginning of your careers, I say, hey, there's a huge amount of new opportunity there. Go learn the new technology, start to understand what's possible here, build applications we've never seen before because it's economically possible, right? And for all us old gray-haired guys out there, help them along, right? Because there's a huge opportunity out there to do this and really transform the business of every business out there. So with that, oh good, I'm pretty much on time. So I'm really pleased to have a great group of panelists here. So I'm going to invite them onto the stage and have them have a seat. If you guys want to ask a question while they're getting situated, I'm happy to do that. Oh, good, a brave person just to break the ice. I think what you're going to see is a new generation of compute and storage cloud services that will be provided. My theory on this is, at the end of the day, if you're an IT professional in a corporation, there's a whole bunch of stuff that you should go, okay, there's other people that specialize in this, so I'm going to let them do it. And there's stuff I specialize in. And the stuff I specialize in, I'm going to sell to everybody else. And I think that's our long-term evolution. So, because there's plenty of specialization out there to be had, whether you want to talk about airlines or pharmaceuticals or utilities or semiconductors, right, all across the board. Whether or not their margins might suffer is another question, right? Oh, go, and then I will. Well, I think this is a little bit of my comment about 30 to 1 and 50 to 1 is a comment that realize in a conventional scenario, what I just said is the guys at Google can drive SUVs into work every day. It doesn't matter. The computers are emitting tons of carbon as by virtue of the power it's consuming, which is why, obviously, if you're not following this, they're all very interested in hydropower and non-heavy carbon energy sources. But I think there's interesting opportunities of what will happen going forward relative to power generation and computing. If you think about it in a very interesting way, it'd be a lot cheaper to distribute bits than distribute watts. And people could start thinking about computing and energy sources linked together, not separated, which is kind of where we are today. I'll do that, and then I've got these panelists which got way more interesting things to say than me. Go. You mean, when you use data at rest, you mean archival information?
Yeah, archival, or just that it's sitting in the database and maybe use as a storage
Yeah, I think the world of storage cloud services is we're very early days of this conversation. Most of the stuff for you technical, most stuff that's going on is object level stores and whatnot, and they're kind of by definition have to be linked closely. So I think there's a lot of innovation left to happen in this relative to how you use archival / disaster recovery services. So, but I'm no expert. I'm just pretending to be one. So I'm going to do this. I'm going to let each of the panelists introduce themselves briefly, and then I have a couple things to start with, but, it'd be fun you guys ask questions too. So go, Stephen.
Thank you. Appreciate it. Steve Philpott, CIO for Amylin Pharmaceuticals. Amylin Pharmaceuticals specializes in developing drugs for the treatment of diabetes, 3 first-in-class drugs, and currently the only diabetes drug on the market that's available once weekly. From a cloud strategy standpoint, we've actually been very early adopters. We started our cloud strategy 2008. Which was probably early for most companies, extremely early for a laggard industry like the pharmaceutical industry.
Norm?
Norm Feldheim. I'm the CIO here at Qualcomm. I think everybody knows what Qualcomm's doing in San Diego. So I've been here quite a long time, 25 years at Qualcomm.
Amy Chu, VP of IT at Sempra. We serve SDG&E, Sempra Corporation, which is the other Fortune 500 in San Diego outside of Qualcomm, as well as SoCal Gas. I think everyone here probably knows what SDG&E does for you. And to the gentleman that has a question about energy and data center, is actually we actually constantly study that because there is a lot of arbitrage opportunity in the energy production and consumption of data centers. And we're looking for opportunities to actually enter that market. So you will see actually people trading power around data center at some point.
We sell power back to SDG&E out of our facilities here and down the street.
So it's actually a very exciting area, sort of in a more distant future.
So I'm going to just kick it off, and I'll start with Amy, ladies first. So just talk about your, what you guys have done to date, and let's call it moving to the cloud, however you want to span the conversation there, and kind of what you think about this going forward. Where's the opportunity? Where are the challenges?
There's huge opportunity for us. We have a lot of legacy systems, really, really legacy systems, that's developed in the 50s, 60s. We also we're in a very different industry than most of these people. We're all regulated to some extent. We are very, very regulated. We can't sneeze without the California PUC giving us permission first. Here's an example. You all get our bills, and you look at the bill. We have different tier rates. And depending on where you live, the rates are applied slightly differently. And depending on what class of commercial, if you run a small shop, you also have different rates. And those rates are modified on a fairly continuous basis. And every 3-4 years is a huge update to it. So we have this huge rate structure that runs on mainframe, runs on COBOL, believe it or not. So we are very, very slow in terms of moving to cloud. There are certain things we're doing that will be on the cloud, certain things that will be on the cloud right away. So there are a lot of new things we're doing. And as you guys have been doing here at Qualcomm, a lot of us in San Diego have been putting solar panels on our rooftop. And that had moved generation from bulk generation to distributed generation. That has a huge impact in the way we keep your power on, because the quality of that current now is no longer in our control. In the past, we will run the power plant, or we contract with power plants who will put out power 400-500 megawatts a block. We actually have services, or they can do ramping up and down to make sure the current is very steady. But when you have solar panels on your rooftop, we can't control that. One, I can't control when the cloud passes over. And when that does is it creates a lot of statics and a lot of noise in the current. And now the current also, this noise is introduced at your homes rather than one central location. So we have to manage that. And in the old days, when we just have refrigerator, that is okay. But now, when we have sensitive equipment like computers or some of your very highly calibrated instruments, that current has to be of certain integrity. So we are putting these things that are still in somewhat of an experimental phase, synchrophasers. They're really detecting the current qualities, and we're measuring it by sub-seconds. So sometimes it's 10 to 100 intervals per second that we will be collecting that data. And once we collect that data, we want to be able to quickly digest the data and diagnose problems in the system that we have. So this is a problem we never had before, because we never had these type of needs nor the equipment. So those type of computing will be done in a very real time. We are in the world of big data or computing. People talk about big data. There's one aspect of data that we care a lot about, is velocity. What is the speed of the data coming in, and what is the speed of the information digested through that data has to go out. And in that particular scenario for the grid operation, that velocity is very, very high. We get a ton. We have to get it out right away. So if there's a system fault, they can do something about it. That's a huge problem for us. Because a lot of people, especially in the big pharma, you guys have a lot of computing. But your time sensitivity is not the same as ours. So we are going to try, in the next year or two, what I would like to do is actually work with a lot of the neural network, machine learning computing guys to take their models to see if they can do it. So there's a real-time sensitivity to their model. And that is going to be something we're going to rely solely on cloud computing, because we can't build fast enough, even if we generate and we don't have to pay for our own SDG&E bill. We just can't do that fast enough. So it will be fascinating. I'm looking to partner up with some of the research institutes as well as the big pharma, because you guys are very advanced in that particular area, in bringing that to the utility industry. So in that side, it's very, very exciting for us.
Absolutely. So Norm, would you talk a little bit about, because I know you're you've been pretty advanced in terms of the adoption of applications as cloud services. Right. So talk a little about that, and then where you guys headed with compute and storage, and you run massive engineering farms here.
Right. We were relatively early adopters of SaaS applications, Salesforce. We went from being 100% Siebel to 100% Salesforce in about 2.5 years. That was functionality and cost driven, and we've adopted other SaaS type applications wherever that's made sense. It's really just, we look at the application, does it work, do we like it, can it run in the cloud? Great, go for it. On the compute as a storage or Amazon, we'll use that, but it's on a selective basis more for our startup businesses where it's time to market and we need to get something up pretty quickly. We do it kind of systematically, but not a lot because we're running so much compute here, my cost for compute and storage is actually less than Amazon's. So for the most part, we run a private cloud and the engineers come to IT to do that. So we haven't seen a big adoption of compute and infrastructure as a service. A little bit of platform as a service, more around Force.com, but it's really been the applications as a service or software as a service that has been the big thing here and a big success for us.
So out of curiosity, have you ever thought about becoming a provider? Because you guys provide, you have a lot of compute and storage capability here around semiconductor simulation, analysis, et cetera. Why not get in the business of doing that?
I mean, we could, I guess. I mean, it's not necessarily, Qualcomm's business model. We're primarily focused on producing chips and licensing our technology. So it would probably be considered a distraction, for the core mission of my department and the mission of the company. But it's certainly something we have the wherewithal to do, and we have some other divisions that are kind of exploring that, but more as delivering services and information as a service versus just infrastructure as a service. So we'll see some of those things come in the future to take advantage of the infrastructure that we have. And we have a lot of servers, and we're 2 for 1 on servers per employee. So we run a lot of compute. So we have that, but I think it'll be more on the way that you're talking about, where it's service and providing those services versus just providing a computer.
Yeah. So, Steve, I mean, I'll just make a comment because I've followed this area a little bit of, I don't know how many of you guys have been following what's going on in both the brain research area as well as genomics, but the amount of computation people are throwing at this problem is just staggering. I mean, 10,000 core, 4 petabyte systems to do genomic analysis. I just read 100 micron slice of brain matter right now is 1 terabyte of information. And if we're going to do a brain mapping thing, I mean, it's gargantuan amounts of data and information. So talk a little about Amylin, the pharmaceutical industry in general, maybe, too.
Yeah, and maybe
where are we headed?
A little bit about how we got started at Amylin. So when I mentioned we started our journey in 2008, and I was really interested in your comment there toward the end about services. And I think that's kind of what got us started on our cloud journey, is we read a book called The New Age of Innovation, and in there they talked about a couple concepts. You hit on one of them, which is kind of that concept of n equals 1, that there's a customer of 1, and to the extent possible, you're using data to deal with that customer on an individual basis. But more importantly, in this book, The New Age of Innovation, they talked about another concept. They talked about this concept of R equals G. R equals G stood for resources are global. And what it meant was, what they talked about was the fact that you as an organization can't have all the resources you need to satisfy your customers. You are going to have to go to external resources in order to leverage and support your customers. The other thing they got across was this point that what you need to do is access resources. You don't necessarily need to own the resources. And I think once we had that concept in our mind, it allowed us to adopt the cloud methodology, the cloud paradigm, a lot easier than a lot of other organizations that still struggled with, well, how do I define cloud? Well, we didn't care how to define cloud. We were like, okay, well, how are we going to use a service, whether we own that service or not? So we started our journey. We created a strategy. The strategy we created was very similar to your slide, which had the 7 different hierarchies. We have a data center as a service. So our entire production data center is in Phoenix. I have no Amlin employees in Phoenix. It's run remotely, and our corporate headquarters is actually our DR facility. So we're kind of completely reversed. We have infrastructure as a service with Amazon. We have software platforms as a service with Force.com and with Heroku, which is their web capabilities. We have storage as a service with Nirvanix, which is a competitor to Amazon's S3. And then from there, we've probably got 4 or 5 dozen other software as a service applications. But the key is you really have to get by that concept of, oh, I need to own the box. I need to be able to touch the box. I need to be able to open a door and look in and actually see the server. And that's not the world that we're going to in the future. And the sooner people kind of embrace that, the better. Now, does that mean that every single application is suitable for the cloud? No. But our job as IT leaders is to figure out what applications are suitable to go in the cloud and what applications aren't mature enough, and start working on the ones that are mature. And so when we started our journey, we worked on the applications that were mature. The ones that weren't mature, as you pointed out, are the regulated type ones, and the farm industry is heavily regulated. So we knew it would take a while for that part of the ecosystem to catch up. But trust me, we had 100 other applications to work on before we even got close to tackling those. But as you start adding more and more to the ecosystem, what it does to your IT organization is it takes them out of some of what we call kind of the KTLO, keep the lights on operations, and it puts them into the higher value activities. It gets your IT organization focused on data, process, and reporting and analytics, which is really where the value of IT is delivered to the business, and it allows these experts to do what they do best, which is a data center or a software. Those are things like in the data center. The people that are running data centers are doing it so much better than we could ever imagine. So why do we even want to compete with that? Email, HRIS applications, CRM applications. It says, hey, let the experts work on those, and we'll focus on the things that are important. The things that are important are the things related to drugs, drug discovery, etc. The other question you asked was, what's happening next? Where do we see it going? So we've built this environment, we've built this cloud ecosystem. What's next? I think the data aspect is the big one, is the big data concept. But the challenge is, as you pointed out, Facebook has lots and lots of computers. They have lots of engineers. They can afford to build a big data architecture. Most organizations can't. So just like we have data center as a service, just like we have storage as a service, what you're going to see is you're going to see big data as a service. You're seeing companies like InfoChimps come out where for the same way you can start up a Amazon service or a Force.com service, you can start up a big data infrastructure and not have to build the hardware, not have to hire the programmers, not have to do anything. So InfoChimps and others that are providing big data as a service are going to allow the 95% of organizations that aren't large and don't have big budgets to get into the big data space.
I love the name.
Yeah, InfoChimps is kind of, I still talk to them. It's kind of a weird business name, but
it sticks.
Yeah, it sticks, and the paradigm that they're building to is spot on, because most organizations can't afford to get into big data yet.
Yeah, I agree. I'm going to open up. I mean, ask any questions coming out of there. I got plenty of questions for them, so go over there in the back.
About going to cloud computing and cloud data storage, what's the concern from an IT perspective of putting that data out there and having that stored in a, whether it be in the United States or outside the United States, and having the legalities of that, the integrity of that data with the IP aspect of it.
That's part of, I don't know who that was directed to, but that was part of the due diligence that goes into, remember I said not every application is suitable to go into the cloud. So what you have to do is you have to have filters that are part of your selection process. A filter might be architecture, a filter might be performance, a filter might be FDA governance. There's certain things that the FDA requires about us that the vendors won't step up to, so I can't move those apps out there. Another one might be around security. Notwithstanding the individual country regulations about whether or not you can store data within a certain country or not, it really comes down to a broader analysis. Now, having said that, there's a lot of tools that are available now that are going to allow you to have more control over where that data is located. There's security companies like Cipher Cloud that will actually allow you to encrypt the data down to a field level, and you own the keys. So it's not somebody else owning the keys, you actually own the keys. So you really have to look at all the tools that are available, but it is a due diligence analysis that you have to check the boxes. Down the third row.
In the front? Oh.
As most of you in San Diego know, is that we had a minor power outage a while ago. If you remember, that basically things were down for about a day, and we were all stuck in traffic.
12 hours.
12 hours.
No. Did I say that? Was I blaming you?
You
No.
said a day. It's
Oh, a
12
day.
hours.
Okay, day. Okay. It was over in Phoenix that was the problem, if I recall correctly.
That
But
poor schmuck.
but it raised the question on cloud applications. You're cut off from your continuous data stream. You have to put in, because you had no internet access. In a lot of cases, people were completely and absolutely down. So it raises the question, when you have that interruption of the data stream, how can cloud applications, if you will, sync up with all the activities that were being, in essence, manually done while the power was down and your infrastructure was down, so you then can, when the lights finally go on again, your bandwidth is up again, you can actually sync in with it.
That would be, that would be part of what I would consider normal disaster recovery planning. No, but that's the due diligence that you would perform as a company. So if our computers go down here and we're forced to do something manually, we would then figure out how to process those manual transactions once the systems were back up. So it's not any different than what we do for preparing for something where a data center went out, for example, if that happened, God forbid. But that's what Steve was saying. It's part of what you do as part of an IT organization and the analysis. And you might invest, as we did, in power generation capabilities. So we had power during that power outage. That was an investment decision that Qualcomm made. If you don't want to do that as a company and don't need to do that, then you have other things that you have to do to prepare for that situation. So these are all things that you would normally do and normally expect an IT department or any business to do. Is think of contingency plans and put your disaster recovery plans and procedures in place.
It was really, that particular outage was very interesting because as I mentioned, the majority of our infrastructure is virtualized. So our data centers in Phoenix, 40 or 50 software as a service applications. So what became the limiting factor was the battery power in laptops and cell phones. So as long as a person had their laptop or cell phone, they could get to all their software as a service apps. We could run the company in San Diego with power out as long as the cell towers were up. But what people were finding is that they were out in their cars trying to keep their batteries charged. So again,
until they ran out of gas, they can't get.
Yeah, until you can't get gas. So again, it's not looking at the things that can go wrong. It's also looking at the diversity that cloud provides you. So in that particular example, it actually gives you a greater diversity out there. So again, it's just as we were talking, it's part of the analysis. For some things, you definitely won't put out there.
I also think that as these services mature, you're going to see a similar regulation that's currently imposed on something called critical infrastructure. For example, we operate transmission lines across different states or different regions, and there is a federal regulation on what is a critical infrastructure to the nation, and there are certain rules and certain security that's required on it, and we know this. And I think as these services become mature, these will be deemed by the government, either at the federal or at the state level, as critical infrastructure.
It's already starting to happen.
Yes, so you're going to have not only the security of the data centers or the service providers' sites, but also how they connect with one another, and redundancy will be required to be built in. So I think that's something we're going to be looking at, and the administration has shown a lot of interest in going down the track in terms of the regulations and law in the cyber area.
You know, you were talking about, you made the comment about pharma and big data, big data sets. One of the interesting things, and I'll use the Amazon example, so you talked about PathWorks and the amount of data. And so for a lot of the pharma industry, they do a lot of computational type work. That computational work leverages a lot of public data. It's public domain data that's out on the internet. There's scripts out there that will allow you to run in Amazon. You can start at one server. You can go up to 30,000 servers over the weekend, over some period of time. But the point I was going to make is Amazon started seeing what was going on. They started seeing a lot of pharma companies pulling these same data sets through the network up to their environment. So what did they do? They went ahead and pulled the public domain data inside their environment. That's the type of efficiency that these type of vendors are giving you. Is you would never think about doing that in your own data center. You just wouldn't. But they can leverage it across a lot of different companies, and now you start benefiting from what they're doing for a lot of other companies. But again, that was just one example that I thought was really, really interesting, where they were looking at how their customers were kind of using the environment and said, how can we help improve that process?
Yeah. You clearly haven't talked to some of the Qualcomm guys, because they would pull it in.
Yeah.
And we have
Right.
on some stuff.
Yeah, well, and there's some stuff that doesn't work, because we wanted to do some search engine analysis, and we again, the architectural review, we took a look and said, oh my God, putting all that data up to Amazon, doing the analysis and bringing it back just wasn't worth it. So in that case, the network became the bottleneck.
Yeah.
I'm going to shift the questioning to a slightly different vein, just for the fun of it. So I'm sure some of you out there are suppliers and whatnot. So these are all decision makers in the purchasing decision. So I'm curious, and I'm going to go through it. What should I not say to a CIO if I want you to buy from me?
What keeps me awake at night?
What is your strategic initiative? A lot of, for us, we really want to get to the bottom of it is, what do you have, and let's discuss what the benefits for me to have that, rather than going through this a sales pitch. A lot of times you come in and then you talk about how you can help, you use all these different marketing terms. Cloud, you're going to put it on cloud, but it's just servers. And then also, what's your strategic direction? Well, I want to be more efficient. I mean, let's not still talk about these things that we all know why you're here. What do you have to offer? What is my problem? And then let's have that discussion on my problem, particular to the solutions that you're providing, so that we can really understand where we fit. It is a two-way interview. I'm interviewing you, you're interviewing me, to see if there's a fit. The quicker we get to that conversation, the more beneficial it is for the both of us.
Norm.
Yeah, no, that's...
I mean, probably the worst thing that people can do from a sales perspective is come in and it's like, what does Qualcomm do? And I get that. I mean, you'd be surprised, And
what's Snapdragon? Oh
yeah. Yeah. So people don't do their homework.
Right.
There's a lot of information out there about what we're doing as a company, what IT is doing, and just doing the homework before you come in and actually have a value proposition that makes sense for what we do as a company and what we're trying to do from an IT organization. You'd be astounded at the people that don't do even the most basic research on Qualcomm or any company.
Or any of the, because they'll come into us with the same thing is they'll come in and ask us, can we help you migrate to the cloud? And had they done the least little bit of research, they would have seen, well, we've been working on it for a few years.
If you do a Google search on Steve Philpott, there's probably a whole bunch of things where you're speaking about all the stuff you've done from a cloud perspective.
So that would be a good place to start.
You'd think.
And for us, publicly listed company, it's a shame people don't do that.
Yeah.
Because all our information is publicly available, and we're required by regulatory agencies to disclose so much. There's so much out there about our companies.
And probably the other big thing is, sometimes I'll talk to vendors for what I call targets of opportunity. I may not have the need right that minute, but I kind of have a feeling in the back of my mind over some period of time I may need that capability. And so I'm looking to understand what their value proposition is so that when we get to that point in the maturity of another project or something else, oh yeah, I talked to ABC, I'm going to give them a call. And so sometimes there is a little bit longer lead time in the sales process. So.
Right, and actually, I would encourage people who have ideas and know our business, and you think you can contribute to our business, to actually contact us, because we're going to start similar to the labs that CommNexus is doing. We're going to do technology forum, because utilities for the longest time has been more of an electromechanical operations, but now it's all digital. So we are making that transformation, and we are really trying to marry up people who are in the operational areas with people with information technology background. And we need to understand how the technologies out there that we have long ignored will impact our operations. So we're actually going to have quarterly forum to bring in our operational people and a lot of these idea people, either startups or different services that we haven't tapped before, to have a discussion on what your technologies would do and what our needs are and how we work, so that you can help us understand perhaps your technology can revolutionize how we operate our grid and serve our customers, which everyone here is our customer, I think. Unless you have solar panels on your rooftop and you have batteries to back it up. So those are the things that we will be doing, and I will really encourage you to contact us so that we could get you there. And as we have always said, read our filings, so that will help you a lot.
I do want to say, don't go too far with the research. I did have a salesperson that looked up my information, my family's information, and actually pretended to be a long-lost friend from high school and presented himself that way. And it was
so what you're saying is don't be creepy about it.
Yeah, it was definitely way over into the creepy factor. Right. So.
Hey, I'll take another question way in the back. Well, no, you would raise it. Yeah. Okay.
I was wondering if you could comment on how you think about public cloud versus private cloud, and whether there's a need for a hybrid cloud.
For us, definitely it's a hybrid cloud. We have a private cloud. We utilize public cloud where that makes sense, and we move back and forth between the two. So you can take either extreme or go with the hybrid cloud, whatever makes sense. It is back to what Steve said. You have to figure out what makes sense for you with that particular application. And a hybrid cloud is a very viable model, and it's part of what we do here at Qualcomm.
And part of what we did was we wanted to have a variety of tools in our toolkit to help the business. So we had private cloud capability, we had public cloud capability, because you don't necessarily know exactly what they're going to bring to the table and need, so you want to have a little bit of capabilities in both areas. The other thing about the private cloud side is most organizations have a fair amount of compute capability already. So we had this concept called optimize the core, is we wanted to take advantage of the hardware we already owned.
Right.
And so, my gosh, set up a private cloud, use the capabilities that you have, before you start going out and buying extra.
And security for us is a huge concern,
Yeah.
so we also have a hybrid approach as well.
Yeah. And regulated. So, as I mentioned, there's certain FDA regulations that may necessitate us owning the application on site for some period of time.
Oh, you have the mic. That's better.
Yeah.
I don't have to
Hi.
figure this out.
Hi, my name is Evie. I used to work at Qualcomm, and I'm working in the healthcare space right now, and I'm also a SDG subscriber.
There you go.
So,
Ding, ding, ding.
right. So you mentioned earlier big data as a service. I'm a little confused with that concept, to be honest, because like when it comes to big data, when it comes to analytics, from a modeling perspective, you have a mathematical model to train, right? And you need a lot of data to train that model. And then when it comes to drug discovery or information technology or energy utilization, you have different mathematical models to train with, right?
Yeah.
And that would dictate whether you do induction or deduction or the different combinations and permutations of those techniques, right? So that's the first question. How can you see a big data as a service across different industrial segments, industries, or markets?
So,
The second thing is, kind of forgot. So go with the first one first.
So in the next couple of minutes, we're not going to be able to have a Big Data 101 session to kind of go through the details. What I think you're going to see is organizations leveraging the capability of big data architectures to augment some of their existing capabilities. So there are certain things that you can do on the big data side that, as we were talking about in the presentation, that you can't do with a more traditional data warehouse database structure. And so the ability to consume lots of data, the ability to consume unstructured data, some of the ways we're looking at it is the ability to consume data a lot faster. So instead of having to go through the traditional modeling that you would do on your normal data warehouse, maybe what you do is you leverage the big data architecture, let it do the first round of filtering, take this large data set, get down to a more kind of finite data set, and then from there use that to plug into your data warehouse, and then from your data warehouse it would plug into your CRM. So it's something that augments it, but I think most organizations don't know how to get started. And these big data as a service companies are going to allow the smaller organizations to kind of dip their toe in the water when it comes to big data and figure out what might I do with some additional unstructured data? What might I be able to do with, kind of a what-if analysis on extra data sources?
I actually think, though, that Tim had it correct. You're going to see specialization.
Yeah.
And you're going to see Flock IT. You're going to see pharma big data as a specialty, and maybe engineering, for me, and energy grids and different things. And so if the industry is big enough and the market opportunity is big enough, the economics of the cloud is going to make business models be able to specialize, and they won't have to sell general purpose services. They'll certainly be that. That's what Amazon has been doing. It's a general purpose. You'll start to see specialization within that that will enable these companies to take advantage of that, assuming there's a market for it. But I think in the areas that you were talking about, definitely there'll be a market for those.
And also, I think you should think about big data as a service more as a data scrubber. That's what Steve is describing. The modeling is still in-house, right? This is just a way of, instead of everyone having to go out buy millions of dollars of appliances, someone is going to do that.
Right.
And you just subscribe to it as you use it.
Yeah, so you could buy it as a full service, so further up the stack on Tim's chart, or you could just buy the big data infrastructure and do the modeling yourself.
Exactly.
So you have choices, back to what we've been talking about all night.
Or point your tools to it. So, whether you're using SAS or Tableau or some of the others. But again, it's going to be a tool for you to use to help augment the way you analyze data.
So it's definitely not a one-fits-all kind of solution when it comes to that. And so,
I don't think so.
right. So when it comes, the second question is that with that, when you invest on this kind of cloud-based software as a service type of platform to replace your old infrastructure, as Amy was mentioning earlier, their solution, existing infrastructure was very, outdated, kind of, right? So with that different industrial segments, you will have different ROIs, right?
Mm-hmm.
Correct.
Absolutely.
So it's 7:45, and I know we could sit here and talk for much longer. I wanted to leave you with two things to think about. One, and I didn't want to do this before I started with you guys asking questions, but I always start out my Stanford class by saying that the mark of a great student is not what they know, but the quality of the questions they ask. So thank you for all the high-quality questions. And as you go forward, think about more high-quality questions. And the second thing I learned here tonight was don't be creepy.
Yeah.
So I want to thank Amy, Norm, Steve, and you all have a good night and drive carefully.
Thank you.